Yeah.
Lesson 1-7, we're going to talk about functions today, folks. Okay, yesterday we talked about relations. A function is a relationship in which each element of the domain is paired with exactly one element of the range. We call each element of the domain the input. We call each element of the range the output. And so what we do is we have a diagram here, and if you notice here, it's got the definition of a function. And then it also shows you what a function looks like in terms of a mapping and what a function looks like in terms of a graph. So we're going to determine whether each relation is a function. So each element of the domain is paired with exactly one element of the range. So is each element here of the domain paired with exactly one element of the range?
No.
Is -2 paired with 1 in the range?
Yes.
Yeah. Is 0 paired with 1?
Yes.
Yeah. Is 3 paired with 1?
Yes.
Yeah. Is 4 paired with 1?
Yes.
Yeah. So this is a function. And so that might be something that you need to do. You might just need to go with that checklist that we just got done doing. So this one does work. Let's look at this next one. Okay. Is 1 paired with exactly one element of the range?
No.
Yes.
No.
Why not?
Because it's paired with 4 and -4.
What do you notice about this?
They traded trios.
The number 1 is paired with how many elements of the range? 2. Okay. So if I were to draw this as a mapping, because maybe that would make a little better sense. Okay, let's draw that as a mapping. Okay, if I draw that as a mapping, 1 goes to 4, 3 goes to 2, 5 goes to 4, and then the very last one, 1 goes to -4. So 1 actually has 2 arrows. It goes to 2 different ranges. So as a result, this is not a function. Okay? So let's go ahead and look at the last one with the ordered pairs. I think that worked pretty well, writing those as a mapping, so I'm going to do that. So I look at my domain. What are the values in my domain?
2,
2 and
3,
3. What are the values of the range?
1,
1,
-2.
-2. So let's go ahead and look at that. 2 goes to 1, 3 goes to -2, 3 goes to 1, and 2 goes to -2. So is that a function?
No.
No, because each element of the domain, in this case, is paired with exactly 2 elements of the range. So this is not a function. Okay? In order for it to be a function, you have to have 1 arrow going from the left to the right. So now we're going to define what's known as a discrete function and a continuous function. A discrete function is a graph that consists of points that are not connected. Okay, so discrete, the points are not connected, they're just points. A continuous function, if you think of the word continuous, it means it goes on forever and ever, it doesn't stop. A continuous function is a graph that consists of a line or a smooth curve. So we will be using these in our problem next. And so let's go ahead and look at this problem. It says, at an ice sculpting competition, each sculpture's height was measured to make sure that it was within the regulated height range of 0 to 6 feet. The measurements were as follows. Team 1, 4 feet. Team 2, 4.5 feet. Team 3, 3.2 feet. Team 4, 5.1 feet. And Team 5 was 4.8 feet. Make a table of values showing the relation between the ice sculpting team and the height of their sculpture. So, make a table. So we could either make the table horizontally, vertically, doesn't matter. I'm just going to do it horizontally just because that'll work a little bit better where I'm at. So I'm going to go ahead and, I don't know, let's do this. We'll do cream. Oops, I did that the wrong way. I flipped them. Okay, about right there. I'll go ahead and change that real quick. There we go. Okay, and so what I'm going to do is I'm going to go ahead and start first with my team. And then what's my next other one going to be? Height. Oh, having trouble with that. There we go. So team, I have 1, 2, 3, 4, 5. Okay. Team 1, how high was it? 4. Team 2, 4.5. Team 3, 3.2. And Team 4 is 5.1. And Team 5 is 4.8. Okay? So, I'm going to go ahead and look at my next question shortly, just a second. Okay, so here we go. It says determine the domain and range of the function. So what I'm going to do is I'm going to go ahead and pull in those same numbers that I just got done doing. Okay, and so here we go. Let's make that a little bit bigger. So I need to determine the domain and the range. Okay, so the domain in this case was the set of first values. So what's my domain going to be here? Yeah, domain is going to be what? 1,
2, 3, 4, 5.
If you're wondering where the domain comes from, that was the team number. Okay, because we have team number on the top. The range is going to be what? 4, 4.5, 3.2, 5.1, and 4.8. So that's all you're doing. You're just taking what you have for the team is the domain, and the range is going to be the height. Now it says write the data as a set of ordered pairs. So first ordered pair will be 1, 4. Thank you. Good. Second will be 2, 4.5. 3, 4, 5.1, and what's 5? 4.8. Okay, so we wrote it as a set of ordered pairs. Then graph the data. So this is what you're going to do. You're going to have your graph right here. 1, 2, 3, 4, 5. Now the question is, how do you graph that? Okay? The thing is, you're going to have to approximate, because you're not going to know exactly where 5.1 is. So we're just going to get somewhat close. So if I have 1, 4, okay, 1, 2, 3, 4. That's going to be about right here. 2, 4.5 is going to be a little bit higher. 3, 3.2 is going to be a little bit lower. Okay, 4, 5.1 is going to be the highest. And then 5, 4.8 is going to be right in there. Okay, so it's just a matter of approximating. It doesn't have to be perfect. I'm not going to sit there and measure and make sure you've got it exactly, but somewhat close. Now I need to determine, is this function discrete or continuous? So let's review back to our definitions. Is it going to be continuous? No, because it's got some breaks. So it's going to actually be discrete. Remember discrete? It was not continuous. It was just points. So the reason why it's discrete is because you just have points here. They're not connected.
If it's continuous, it usually has arrows.
Yep, if it's continuous, it'll have arrows. It'll be like a line. Okay, so let's go ahead and look here. Vertical line test. This is probably the most important test you're going to learn, probably this year. Okay, the vertical line test is very, very easy. What it states is that if you want to determine if a graph is a function, you're going to take a vertical line. You're going to move that vertical line over the graph. As you pass it over the graph, it can only touch the graph at one point. If it touches more than one, it's not a function. So let's imagine I have a vertical line here. Okay. All right, let's drag that baby over here. So I'm going to move this vertical line through the graph. Okay, you could use your pencil even too. At any given time, does it only touch the graph at one point? Yeah, so this would be considered a function. So function is going to be my answer. Yay, we're done with that one. Let's look at the next one. Next one. Because right now it's touching how many points? 2. So this is not a function. Okay, let's look at the third one. Is it still only touching 1 point, or is it touching 2?
1.
Okay, that open circle means we don't include that. So that's kind of like a hole in the graph. So when I go back, wrong one. There we go. When I go back here, I'm actually only touching 1 point. I'm only touching the circle at the bottom. So this, in fact, is a function. so that's what you do. Take your pencil, move it over the graph. It can only touch at one point. Okay, so determine whether the following graphs are functions. And so what we need to do here, okay, is we need to go ahead and graph this. And so in order to graph this, we're going to use what's called a T-chart. Yes, you will probably need some graph paper. Okay, and I'm going to plug in values. Now I've got one little problem here with this, well, I can use this one. I'm going to go ahead and use the numbers -1, 0, 1. Why do I use those? Because then I don't have to make my graph very big. Okay, by picking those, you can pick 0, 1, and 2. The biggest thing is you need to have 3 points. So I'm going to go ahead and plug in -1 in here for x. So what is -3 times -1? 3. So I have 3 plus y equals 8. What does y have to be there, folks? 5. Now I'm going to do the same thing with 0. I'm going to plug 0 in here. So what's -3 times 0? 0. So I've got 0 plus y equals 8. What does y have to be? 8. And then last but not least, I'm going to plug in number 1. What's -3 times 1? So I have -3 plus what number equals 8. Now, if some of you are wondering how you do that, all I have to do, add 3 to both sides, and what do you get y to equal? 11. So that's your value. So what I need to do is these are ordered pairs. I'm going to go ahead and graph this. So I got to start here, first of all, with my, what axis is the horizontal? X, good. Then what's going to be my vertical? Y, very good. Okay, nice job. That's important, especially on your test, that you get those right. So -1, 5 means you're going to go what from the origin?
We're gonna go left.
Left 1, and how many?
Up 5.
Up 5, so there you go. 0, 8. 0,
Up 8.
and then up 8. So, did I do that? 1, 2, 3, 4. Okay, next one. 1, how many? 11. So, to graph this, I'm actually going to connect those. Okay, and so if I connect those, I'm going to go ahead and draw my line through. Okay, one of the important things to remember here is that you've got to have arrows. And now I have to determine, is that a function? So if I pass my vertical line over, is that going to be a function? So your answer is yes. Okay, questions? Yes, sir.
How did you get -1, 0?
I just picked those. I randomly picked 3 points. The reason why I chose -1, 0, 1 is because if I'm going to draw my graph, I've always got to put the coordinate plane, right? I've always got to put my x and y. So I picked 3 values around there. What you could have done is you could have done 0, 1, and 2. Okay. I just like to pick those 3 because they're right around the middle. Yes?
Can you go over again the figure out what it's a function of?
Yep. We're going to, you know what, we're actually going to go on to the next problem, and then we can hit that. Okay? So I'm going to go ahead and stop because I think I'm getting close to, never mind, I'm going to keep going with the video. So. Okay, so let's look at this one. Determine whether it's a function. So 4x equals 8. So this one's a little bit different, right? How's it different?
There's only one variable.
There's no y. So if I solve this for x, what do I get?
2.
I get x to equal 2. So let's think about that. X equals 2. X equals 2. Where does x equal 2 on my graph?
2 to the right.
X equals 2 right here, right?
Yes.
Does x equal 2 here?
No. Yes.
Does x still equal 2 here?
Yes.
Does x equal 2 here?
No.
No. What about down here?
Yes.
Does x equal 2 here?
No.
So would x equal 2 up here?
Yep.
So x equals 2 anywhere vertically, right? So if I draw my line in here, now, my next thing I need to do is figure out if this is a function. So what I'm going to do to figure out if it's a function, I'm going to take my vertical line. And so I can draw one in if I wanted. Okay, I'm going to take my vertical line right here, and I'm going to go ahead and go left to right on my graph. And as I go left to right, does it only touch at one point?
No.
Yes.
How many points does it touch here? A boatload. Yeah, it touches a ton. So is this a function? No, that is not a function, because at this given point, it's gonna touch a ton of points. So this is not a function. Now, on that problem before, okay, as I pass the vertical line over, so if I pass the vertical line over on this page, at any given time, it's only gonna touch one point. Is that a little clearer? Okay, so now, very last thing we're going to talk about is function notation day. Function notation, basically when you think of equations, you might see something like this. You might see y equals x minus 4. So what mathematicians thought, oh, well, this y is too easy. So what we're going to do is we're going to make it a little bit more academic looking, and so we're going to use f of x. And so they're saying that instead of having y equals x minus 4, we're going to put f of x here. Okay, so when you think of the word f of x, think of function of x. So f here stands for function of x. That's all function notation is. They've taken y out and they put f of x in its place. So f of x is nothing more than y. Very last thing we're going to do then is we're going to plug these values in. And we've got a couple of these we're going to look at. This one says for f of x equals 2x minus 3. So remember again, what this means is this just means y equals 2x minus 3. So when I want to find f of 1, what I'm going to do is I'm going to plug that in wherever I see x. So I see an x up here. I'm going to plug 1 in for x. So that means I'm going to take 2 times 1 minus 3. What is 2 times 1?
2.
Minus 3 is?
-1.
Negative 1. There you go. The next one, I'm going to take negative 2. And I'm going to plug it in up here for x. So this means 2 times negative 2 minus 3. What is 2 times negative 2? Negative 4 minus 3 is? Negative 7. Okay, because you have two negatives, negative 4, negative 3. This next one, let's take f of 5. So that means I'm going to plug 5 right up in here. So this means I'm going to take 2 times 5 minus 3. What is 2 times 5? 10 minus 3 is? Now this is different because notice these two values. We've got to bring it down. So we've got to bring down the 6 minus 7. So your answer is negative 1. And the last one, f of negative 1 plus f of 2. So let's start with f of negative 1. F of negative 1 is 2 times what? Negative 1 minus 3. So what is 2 times negative 1? Negative 2 minus 3 is? Negative 5. That's part of it. Now I got to do the second part, f of 2. 2 times 2 minus 3 is? 4 minus 3 is 1. So it says we're going to add them together. So what is your final answer? Negative 4. Okay. We're going to look at one more, which is a little bit more in depth.
That is very colorful.
Like that? Okay, so here we go. F of 4. Where are you going to put the 4? Where there's an x. Now the question is, what do you do first? Do you do the 2 times 4? Or do you do the 4 cubed?
4 cubed.
4 cubed, very good. So I'm going to do the 4 cubed. So 4 cubed, remember, is 4 times 4 times 4, which is what? 64. Okay, so 2 times 64. What's 2 times 64?
128.
128. Why didn't hear any of you answer in? Okay, so here we go. There's nothing wrong with taking a chance. Okay, so here you go. F of negative 5. Let's plug it in up here. So now the biggest thing here you need to understand, I'm going to put the negative 5 in parentheses because I want to make sure the negative stays with the 5. Okay, so what this means is this means negative 5 times negative 5 times negative 5. Okay, so first of all, negative 5 times negative 5 is what?
25.
So now I've got 25 right here. I've got to take that times an additional negative 5. Negative 125. Okay, so if you double 125, what do you get? Negative 250. For those who are wondering how people can get it, if you think about it in terms of money, This is like $1.25. So if you double $1.25, you actually have $2.50. Okay, this next one's kind of a little tricky, and that's why we're going to look at this. This says f of t.
There's no T? Or is?
So when I had a 4, I plugged it in for x. When I had a -5, I plugged it in for x. When I have a t, I'm going to plug it in for x. So really, I'm going to take that t, and I'm going to plug it in right up here for x. And so what that states is I'm going to get 2t cubed. You don't have to do any math. That's it. That's it for the f of t. Now what we need to do is we need to do the next step, which states I'm going to bring the 3 down, and then I'm going to add 2. So if I take 3 times 2t cubed, what do you get? 6t cubed plus 2. And there you go. You can't simplify that anymore. All right, f of -3, f of 1. This half of the room, I want you to do the f of -3. This half of the room, I want you to do the f of 1. Okay? F of -3, split. That half is f of -3, that half is f of 1. I need you to find that value real quick. So f of -3. You already got yours, the f of 1 group?
Yeah.
What is it?
2.
2, good. F of -3, you guys kind of had the tougher one.
Oh, duh, it is 1.
What did you do, Chicago?
So what's the f of -3? Negative what? I heard -54. Did somebody else get it? Okay, we got a second. There we go. So -54 minus 2 is what, folks?
-56.
-56. Okay, so had a lot of stuff about functions today. Okay, your assignment then for tomorrow is as follows. On pages 52 and 53, I need you to do 20 through 48.
That's all of them.
So pages 50, all.